Configuring the fuel system means telling the ECU about the size of the injectors fitted, as well as how they should be operated. The Motec M150 is quite advanced here and allows complete characterization data for the injectors to be entered. This provides very accurate control of the fuel delivery, but also requires detailed information about the injectors fitted to the engine. If we go to the fuel injector sheet in the initial setup workbook, you can see we have a number of settings that need to be configured. Firstly, we have minimum volume, reference flow, and reference pressure for the injectors. The critical part though is the linearization table, which is a 4D table that defines injector flow based on pulse width, fuel pressure, and battery voltage. From these parameters, the ECU knows exactly what pulse width is required to provide the required fuel flow. The way the M150 deals with the injector setup is quite advanced and still not too common, so we're going to look at the settings in a more conventional Motec 100 series ECU-T. In the 100 series, the injector operation mode is defined partially by the trigger mode the engine uses. Where possible, we want to use sequential injection, where each injector is operated separately, and this requires that the ECU has a sync input to tell it where in the engine cycle it is. When configuring the fuel system, we start by setting the type of injector that we are using, either peak and hold or saturated drive. Motec defined this with the injector current and peak and hold ratio. Be aware that some ECUs are not compatible with low impedance peak and hold injectors without adding a ballast resistor. The next setting we have to adjust is the injector dead time table. This is a simplified version of the injector linearization table in the M150. Motec refer to this table as injector battery compensation, while it's also known as injector dead time or injector latency in other ECUs. This table requires some detailed injector data so you can fill it in properly. Fortunately, this data is available with most quality aftermarket injectors. If your ECU uses a millisecond based main fuel table, you'll need to set a base injector pulse width, which basically calibrates the fuel output. This isn't necessary with the M150 since it uses a proper volumetric efficiency based fuel delivery model. In Motec's 100 series ECU, this base pulse width is referred to as injector scaling. The number here refers to the injector pulse width supplied with a number of 100 in the fuel table at 100 kPa manifold pressure before any compensations are applied. We want to select this number to give us good resolution in the main fuel table. The correct number will depend on the size of the injectors, the fuel pressure, and how much power we expect to make. While you can calculate the likely pulse width using an estimate of engine VE and the calculations we learnt in the EFI Fundamentals course, it really isn't necessary since we can tweak this later as we'll see. I will normally start with a master pulse width of around 10 to 12 and adjust this later once we have the engine running. Once we have the fuel configuration complete, we can test the injector outputs. Most ECUs provide a test output mode, which can be used to drive an output and test it's working correctly. The M150 has a special test mode where the test RPM can be set, and each output can be tested as if it was operating at the test RPM. We can use this to test each output individually. We're going to start by selecting a test RPM of 2000, and we can use the test output to select each injector output. When you do this, you want to make sure that the fuel pump is not operating, as otherwise you'll end up injecting fuel into the engine. While you're testing the injectors, you should be able to audibly hear the injector operating, and you can isolate and confirm the correct injector is operating. You can confirm this by unplugging the injector. This is a great way to confirm the injectors have been wired in the correct firing order. Now we can move on to the ignition system.